Okay, first we're going to evaluate logarithms by using conversion. You recall that you can change an exponential form into a logarithmic form. We're going to take these logarithms and turn them into exponential form, and then we should be able to evaluate them. I have a chart over here that should help us with some of the numbers, especially our powers of 10. So base of 2 to the power of x is equal to 32. And then once we change it into exponential form, it becomes pretty easy to solve it because we know that x is going to be 5 because 2 to the 5th is equal to 32. Okay, let's change the second one. The base is 8. 8 to the x power is equal to 1. Well, we already know that anything to the 0 power is equal to 1. So x to the 0 power is equal to 1. Okay, the next one we've got 4 to the x power is equal to 2. And this one, we take x to the 1/2, and then we have 2. So if I take 4 to the 1/2, you can turn that into a radical, and that's to the first power with the index of 2, and you will see that that does equal 2. Okay, log base 10, so 10 to what power is equal to 1 over 100? And x is going to be equal to negative 3. 10 to the negative 3 is equal to 1 over 100. Okay, we have some logarithmic properties here, 1, 2, 3, and 4. I'm going to break down each one of these and show you how to use each one. The first one, log of any base of 1 is always equal to 0. So as long as I have 1 here, then it will be equal to 0. This is from property 1. So it doesn't matter what the A is, as long as it is 1 right there. This is log base 10. Recall that if we do not have a base, that it is base 10. Okay, property number 2. As long as the base of the log are the same number, then the answer will be 1. So all of these are the same. We don't have a base right here, so recall if there's no base, it's going to be a base of 10. So this again here is 1. Okay, number 3 is the inverse property. So I'll do the first one the first way. As long as our base is here, then the answer is going to be the exponent. Same here, as long as these two match, then the answer will be our exponent. And then the opposite way, as long as the base here is the same, then our answer is 8. And here our answer is pi, because the 4's match and the 20's match. The one-to-one property in number 4. What it says is if you have the log base and the base is the same, then you are allowed to let x be equal to y. So here, as long as our base is the same, then you set these equal to each other. Bases are the same, set them equal to each other. And then same here, bases are the same, so we set them equal to each other. So in the first one, I write x is equal to 12, and we're done. We solved it. The second one, x plus 6 is equal to 20. Subtract 6 from both sides, and I have that x is equal to 14. 3. In the third one, I have x squared plus 3 is equal to 12. Subtract 3 from both sides, and I have x squared is equal to 9. This is the square root property. You take the square root of both sides, and then I get that my answer is positive and negative square root of 3. Logarithmic properties. Next, we have natural log properties. Natural log is going to be denoted by ln. So we have 4 natural log properties here to go over. In number 1, the natural log of 1 is always 0. The natural log of 1 is always 0. So natural log of 1 is 0. I have 8 in my denominator, and 0 divided by 8 is 0. Okay, the natural log of 1 is always 0, and 4 times 0 is 0. In number 2, the natural log of e is 1. The natural log of e is 1. So I have 4. The natural log of e is 1. And 4 times 1 gives me 4. I have 2. The natural log of e is equal to 1, and that's over 8. So I have 2 over 8, and that simplifies to 1/4. In number 3, the inverse property, the natural log and e are inverse properties, and you end up solving this out by just taking the exponent. So the natural log of e to the 7th is equal to 7. 3b, if we have e to the ln, again, they are inverses of each other, and our answer will just be pi. Property number 4 is exactly like the logarithmic 1-to-1 property. Natural log of x equals natural log of y. As long as you have natural logs on both sides, then all you have to do is set them equal to each other. So as long as we have natural log and natural log, again, you can just set them equal to each other. Okay, evaluating logs and natural log expressions. If the expression is given in base 10, then you can put it in the calculator because the calculators are written in base 10. So as long as there is no base, then we know that it is base 10. So we just throw these into our calculator. You will notice when I put in a negative number, I'm going to put it in parentheses also, cannot get an answer because there is nothing. 10 raised to any power is never going to give us a negative number. So this one is undefined. Let's do some natural logs. Very good. So as long as they are written in base 10, all you have to do is put them in the calculator. Okay, so what do we do if they are not in base 10? If they're not in base 10, you are allowed to use a change of base formula, and the change of base formula is over here to the right. It says that you take the log of the x value and divide it by the log of the base. So I have these over here written for us. I already have them written out. Log of 25 divided by log of 4. You can also use it and use ln if you would like to. So if I put in ln of 25, ln of 4, I will still get the exact same answer. Okay, let's try. Let's put these in the calculator and see what they look like. And you will see exact same answer. Okay, so again, you can do it either way. You take the log of the big number and divide it by the log of the small number. And you are free to also use natural logs. You will still get the exact same answer. So again, this is change of base. We'll get this last answer here. Okay, so this is change of base. If your base is not base 10, therefore you cannot put it into the calculator, then we will be using change of base formula, and then you'll be able to solve them. And then you just put them in the calculator and divide them. Hope you enjoyed logarithmic properties and evaluating with base 10 and evaluating with change of base. Hope you enjoyed.